Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the Teleconnections discussion for the 7th of January 2022. And this is a little bit of the hints of the theme of this week's Teleconnections discussion. If you live in, let's say, the Midwest, Northern Plains, over to the East Coast, we're going to be talking about bundling up a lot in this video about Arctic air intrusions. In fact, I released my latest blog today, and I titled it Release the Arctic Hounds. And here's a couple cute pictures of some dogs all bundled up for the winter weather. If you like dogs and have dogs of your own, you definitely can relate with this. But in general, it's going to be time to bundle up. And so let's get right into tonight's discussion. Right, so the first thing I want to do, like I usually do every week with Teleconnections discussion, is I want to go ahead and set up a general tool here to highlight certain areas that I'm really tracking in this week's Teleconnections discussion. The first thing we're going to do is start with the Northern Hemisphere, and we're going to look at the 500 millibar, the heights and the anomalies in meters. In general, on this particular graphic, if you see a maroon or a lighter white shading, an orange coloring, that indicates an upper level ridge, which is indicative of milder temperatures and usually dry conditions. Where you see the green shading and the blue shading, that is indicative of a trough, an upper level trough, at about 500 millibars or 18,000 feet above the ground. And when you see these green and blue colors, these troughs, that's indicative of colder temperatures and more unsettled conditions typically. So we're going to go ahead and take a look at the Northern Hemisphere and kind of see what's happening as everything is connected. We'll start off with looking at this huge upper level ridge extending from eastern Siberia to Alaska. That's generally in this location here, with an upper level trough beneath the ridge over the north central Pacific to the northwest of the Hawaiian Islands. And this is a classic looking, what's known as a negative Western Pacific Oscillation, or WPO, where you get an upper level ridge over this trough. And I have a following slide here to kind of show you what a negative WPO, Western Pacific Oscillation, this type of dipole or pressure configuration, what it generally means for the United States weather during the winter season. So now we're going to work our way east. We're going to talk about this upper level ridge, which extends northward into the Gulf of Alaska. And as we continue to work our way eastward, there's an upper level trough that extends basically from western Canada right on down into the Midwest and the eastern United States. And we do have an upper level ridge. It's located right over the Northwest Atlantic at the present time as well. And then moving eastward, we have upper level trough from Greenland. Greenland's basically at this location, and that's basically working its way. The trough axis is working its way back towards the British Isles, back towards England, and then over the west central Mediterranean, we also have another trough, upper level trough, over the west central Mediterranean, just to the east of the Strait of Gibraltar. And additionally, there's upper level ridge over far northern Europe in this location, over far northern Europe, to the Arctic Ocean, extending northward to the Arctic Ocean, and over the Saudi Arabian Peninsula there is another upper level ridge. So we do have a lot of ridge trough couplets, and again, I want to point this out over the Pacific. This is your classic looking negative Western Pacific Oscillation, or WPO pattern. So a lot of interesting things I'm noting on the 500 millibar geopotential height and the anomaly in meters. So now, what exactly is a negative Western Pacific Oscillation? Now, these graphics are courtesy of the World Climate Service. I got this right off that particular source. And in general, the graphic on the left here shows the pressure pattern at 500 millibars at that 18,000 foot level, the mid-levels of the atmosphere. And generally, when you see these orange shadings and yellow colors, that's indicative of upper level ridge. And the blue shading is indicative of upper level troughs or lower atmospheric heights. And look what you typically get. You know, we looked at this previous slide. This is right now for today, the 7th of January, 2022. We have upper level ridge extending northward into the Bering Sea, and we have a upper level trough beneath that. And if you look at this graphic here, very similar. The orange shading would be indicative of a negative Western Pacific oscillation with the upper level ridge extending from eastern Siberia into the Bering Sea. And beneath that, to the northwest of the Hawaiian Islands, you see this dark blue shading. That's indicative of an upper level trough. So it's an amazing match between now, what's going on actually today in the mid-levels of the atmosphere, and the graphic on the left, which shows a negative Western Pacific oscillation. Additionally, the graphic on the right shows the general temperature anomalies at 2 meters. The blue shading is indicative of the percent of years having above trend December through February 2 meter temperatures. So you see this blue shading here. That's generally indicative of colder temperatures from the central U.S. to the East Coast, and this kind of like this rosy color here over the U.S. Southwest is usually where the milder temperatures reside, with a negative WPO. So overall, the Western Pacific Oscillation is a pressure dipole that exists between the Bering Sea and the Pacific Northwest, in the Pacific Northwest of the Hawaiian Islands, that influences the downstream pattern across much of North America. So we are forecast, by the way, to remain in a negative phase WPO right on through early February. So I wanted to kind of start things off differently tonight and show you a different oscillation. I don't normally talk about this one, but this also plays in to what happens downstream in across North America. How does the jet stream pattern set up? Where are your colder locations and troughs? Where are they set up typically with a negative WPO? Where is your ridges set up with a negative WPO? So it's really interesting. Ridge along the western U.S., trough in the central and the eastern U.S., and what do you know? A ridge along the west coast, and then you get the troughing from the northern plains working its way towards the east coast. All right, so now let's take a look at the Madden-Julian oscillation, the phases and areas of enhanced convection. As a reminder, the MJO ranges from phases 1 through 8. In general, you see with MJO that phases 1 and 8 are typically associated with upward vertical motion or convection along the international dateline, as well as right off the coasts of South Africa, the west and east coast of South Africa. And then upward vertical motion and convection when we get in the Indian Ocean, that location where MJO phases 2 and 3, and then the maritime continent 4 and 5 would be the MJO phases 4 and 5, where we see more upper vertical motion or convection over the Australian continent, and then phases 6, 7, and then again working our way towards 8 near the dateline. This generally shows you where the upper vertical motion and convection occurs. All right, so let's take a look at the satellite imagery here for the Pacific, North Pacific Ocean for today, 7 January 2022. In general, we have this deep area of low pressure that's extending south of the Aleutian Islands, with a frontal system extending southwest from this particular low pressure system. So it's a pretty intense storm system situated south of the western Aleutian Islands. And then we have an area of high pressure, generally in between that particular storm system and then another storm system there off the Pacific Northwest coast. And there's a long fetch of moisture which goes all the way down into the tropical Pacific, and it's generally extending from tropical Pacific up into Northern California, eastern parts of Oregon and Washington State. Looking at the Western Pacific here on the right-hand side, the infrared image for the Western Pacific today on the 7th of January. I've noticed some changes since my last video. The convection across the Western Pacific has diminished somewhat or decreased and become less organized. So we're seeing less organization to the convection. The upper vertical motion is not as strong as it once was, especially when we were back in December, sitting in MJO phase, initially phase 6, and stalling out in phase 7. We had a lot more thunderstorm clusters out here in the Western Pacific, east of the Philippines. And now we worked our way towards phase 8 of the MJO. If you look back at the graphic here, phase 8, we'd expect convection to be located near the international dateline at 180 degrees west longitude, as well as potentially there off the western coast of South Africa. So let's take a look at the MJO and the forecast by the models, looking at the new temperature composites now that we're in the month of January. So we look at the temperature composites for January, February, and March, and you'll notice phases 8, 1, 2, and 3, the blue shading is generally indicative of below normal temperatures. So the phase 8, 1, 2, and 3 are associated with cold temperatures across the eastern United States. Phase 3 is associated with quite a below normal temperature setup for most of the United States, from the west to the east coast actually. Now if we were to go into phases 4, 5, and 6, and 7, the eastern United States would be above normal with temperatures when we have MJO phases 4 through 7 during the months of January, February, and March. So let's take a look at the latest GFS Ensemble forecast. That's the green line here. And I tell you what, this has been a really stubborn situation. Back, I'd say about the 21st, 22nd of December, the models were indicating this to go over to phase 8 and phase 1 and remain fairly significantly amplified, the MJO pattern, where the convection upward vertical motion was going to shift from that western Pacific area and move into more of the West Hemisphere African area in phase 8. But that did not materialize. All right, it stalled around here in 8. You can see these maroon lines here. This shows you the dates. Generally in December, this thing just kept rotating around in phase 7 and just seemed like it was stuck. And so, typical La Nina pattern, we had upper vertical motion in the Western Pacific. This matched up well, and it was just so stubborn. Well, now we're actually in phase 8. All right, now, if you want cold air in the east, phase 8, you need to get that MJO into phase 8, and we finally have succeeded. These yellow lines represent the different ensemble members. Generally, there are some ensembles still showing some fairly significant amplitude into phase 8, and then a rotation around into phase 1 and phase 2, where the upper vertical motion and convection shifts to the Indian Ocean. Now, this particular forecast for the MJO goes out through January 19th, 2022. So we're in phase 8 now, and if you look at the green line, the ensemble forecast, the mean of all the members showing us going into this smaller inner circle again towards the 19th of January, and that is the null phase, where the MJO becomes less active. Looking at the GFS Operational forecast here on the left, all the way out through the January 19th as well. Again, I laugh at it because, as a winter weather fan, everybody was talking about this on Twitter, and, everybody wanted this MJO to get into phase 8 so badly. Anybody who lived east of the Mississippi River did, because it was such a mild December. This MJO just kept sitting here, and upper level ridge just remained over the very far western portions of the Aleutian Islands and the Bering Sea, and it never moved, the ridge. And so we had a persistent negative PNA. We had a trough along the U.S. West Coast. We had this massive southeast ridge that built up the eastern seaboard, and everybody was like, where is winter at? Even in southeast Virginia here, where we're located, January 1st and 2nd, we had high temperatures in the 70s. I mean, one of the days was 77 degrees, and wow. But getting back to the discussion here on the forecast, this is the GFS forecast is this aqua color line. It's also showing a rotation into phase 8 and then ultimately going into a null phase. The CFS V2, the CFS forecast for the MJO, you kind of can see where it was in phases 6 and 7 for a good chunk of latter December, and now it's finally rotated into phase 8, and then it kind of goes towards null phase, but then comes back out. Some of these models are forecasting it to come back out of that null phase and come out and get more amplitude into phase 1 and phase 2 with time. So we're going to have to pay attention to this. Now this graphic, by the way, on the right is courtesy of Kyle McRitchie. Let's take a look at the La Nina update. This has been going on for quite a while now. Definitely impacting the upper air features and the pattern overall, the jet stream configuration. The La Nina this winter. Right now we're sitting at about 1.04 degrees Celsius below normal water temps in the Nino 3.4 region. That indicates a moderate La Nina. So we have a lower end moderate La Nina. If you look at the latest temperature departure, water temperature departures here on the left, the blue coloring indicating below normal temperatures, the orange shading indicating above normal temperatures. So really no changes. If you've watched my past 3 to 4 videos, this particular sea surface temperature departure map has remained fairly the same, where we get this blue shading below normal water in the Gulf of Alaska down the U.S. West Coast. And then we get this, of course, this is the La Nina signature with the below normal waters over the equatorial eastern and central Pacific, all the way out close to the dateline. And then you have above normal water temperatures in the north central Pacific. Now there is one difference I've noticed recently is this blue coloring has grown a little bit. And that's generally to the southeast of Japan over the northwestern Pacific. We have cooler than normal waters that are now situated out over the northwest Pacific, so that's real interesting. Overall, let's move on. The intensity classifications again of La Nina. We're paying attention to the water temperatures in the Nino 3.4 region. That's what NOAA uses and looks at to determine whether we have an El Nino or a La Nina or ENSO neutral conditions. In general, we're sitting at negative 1.04 degrees Celsius below normal water in this Nino 3.4 region. And so we're in moderate territory for La Nina here on the 7th of January, 2022. These are the coordinates, by the way, for the Nino 3.4 region, bounded by the latitudes 5 degrees north to 5 degrees south, and bounded by longitudes 120 degrees west to 170 degrees west. Now, I threw this slide in here. This is a latest La Nina forecast. I wanted to show this to you. In general, what we're looking at over here on the left is produced by, this is courtesy of the latest Climate Prediction Center forecast discussion for La Nina. Generally, these are the percentages, and the blue bars are indicative of a La Nina. So for November, December, and January, there was a 100% chance of La Nina. Now you notice how these blue bars, these indicating La Nina, how they tend to get shorter and shorter and shorter with time. That's indicating that the La Nina will be on a weakening trend, especially as we get towards March and April. We're going to see a major drop-off in the probability of a La Nina. Now the gray bars, on the other hand, you'll notice these are growing taller from left to right on this particular chart, and that's indicative of ENSO neutral conditions. So when you see these gray bars growing taller and taller, this is increasing our probability or percentages to see ENSO neutral conditions as we head into the spring and summertime. And then the red bar is indicative of El Nino conditions. So you'll notice the El Nino, these red bars start getting taller and taller as we get closer to late summer, early fall. So overall, what we're looking at is a weakening La Nina over time, and then that's going to be potentially replaced by this ENSO neutral condition, these gray bars, as we head into late spring and through summer. Looking at the graphic on the right, this shows the model predictions. Now this does go back from December 2021. I didn't see any new updates on this yet for January 2022. But as of last month, this is what we were looking at. We're looking at generally December, January, February, where the general middle ground of all the models is showing about a 1 degree Celsius below normal water temperature in that Nino 3.4 region. And over time, you see how the temperature departures, those cooler water temperature departures, tend to work their way back towards neutral, towards the zero line. So that's matching up quite well with these probability forecasts on the left. All right, so now let's go into the actual teleconnections. All right, so for the Arctic oscillation, if you look at the graphic on the left here, it shows what the typical weather pressure features, generally what we're looking at for a negative Arctic oscillation. And really to break this down in a Reader's Digest version, we get a strong upper level ridge over the northeastern Pacific into the Gulf of Alaska with a negative AO. And then you also get much colder air. This ridge extends into western Canada along the U.S. west coast where it's warm and dry during the negative AO. And you get cross-polar flow to set up with very cold Arctic air working its way into the United States with a negative AO. The Hudson Bay polar vortex shifts into a position which delivers Arctic chill. And boy, I'm going to show you some cool graphics here in a bit on the polar vortex forecast. Overall, on the right here, we have the positive AO, a little bit of different story. We have low pressure systems in the Gulf of Alaska, as well as around the Greenland area, and we have higher pressure to the south of that. So with a positive AO, you got lower pressure over the Arctic, you got higher pressure over the mid-latitudes, and you get a more west to east jet stream in which you have less cross-polar flow, more west to east flow, zonal jet stream, and you got Pacific air flooding the North American continent. All right, so let's take a look at the forecast. European deterministic AO forecast for today, 7 January, showing a positive trend of the AO, trending towards neutral conditions by the 9th to the 10th of January, and then moving back positive and then back down negative again. So a lot of ups and downs here in the AO forecast according to the European deterministic model. The European EPS AO 50 perturbed members showing again a slightly positive AO, transitioning to neutral conditions, and then working its way positive, back down to neutral, and slightly negative, and then back to neutral again. So positive through about the 15th of January for the AO, then neutral. Looking at European EPS, AO 50 perturbed members, if you look at this green line, this is your ensemble mean or average, generally showing a positive AO, working its way towards neutral around the 10th, positive again through about the 16th of January, and then neutral to positive beyond the 16th of January. Looking at the GFS deterministic AO forecast, showing a positive trend of the AO, working its way towards neutral, then back positive, then back neutral, then negative, negative after mid-January. And it remains fairly negative throughout. And then the NCEP GEFS V12 AO, 30 perturbed members showing a positive AO, dipping down slightly below to negative territory, then back positive, and then back down below to negative territory after 15 January. So GFS and GEFS, general agreement that the Arctic Oscillation may dive negative after the 15th of January, after mid-month. Looking at the North Atlantic Oscillation NAO forecast, generally showing you the differences between a positive NAO phase on the left and a negative NAO phase on the right. In general, with a positive NAO phase, you get the coldest temperatures remaining over the northern latitudes, milder temperatures along the east coast of the U.S. Also warm and wet over the northwestern portions of Europe, British Isles on into Sweden, Norway, Finland. It's above normal precip and generally milder with a more zonal west to east Atlantic jet stream. With a negative NAO phase, things change dramatically because you get a huge trough in the eastern United States where you get below normal temperatures that are coming down from Canada into the base of the trough along the eastern seaboard, and you get also, if you get the right mix of cold air and coastal storm development with a negative NAO, you can get a pretty significant snowstorm. Notice the blocking that's associated with a negative NAO on up into Greenland. This is a blocking ridge. And then you get a dip in the jet stream over Western Europe, and it tends to get warm and wet over the Mediterranean Sea. So let's take a look at the model forecast for the NAO. For the European deterministic, for today, we're showing a positive NAO, transitioning closer to neutral by the 9th to the 10th. Positive again, and then it dips down negative to neutral, generally after the 14th of January. European EPS, NAO 50 perturbed members, showing a positive NAO for today's date, the 7th of January 2022, dipping closer to neutral by the 9th and 10th of January, back positive, 12th to the 13th of January, back negative, around mid-month, and then more close to neutral after the 15th of January. European EPS, NAO 50 perturbed members, showing a positive phase of the NAO, dipping down slightly, back up positive, then back down towards neutral around 16 January, and then back slightly positive through all the way out through 21 February with the European EPS 50 perturbed member model. In the GFS deterministic NAO forecast, generally showing a positive phase today of the NAO, dipping down to neutral around the 10th of January, back positive, the 12th to the 13th of January, back down negative, dropping negative around mid-month, according to the GFS deterministic model. and then back towards neutral around the 19th of January, and then really hanging around neutral after that. NSEP GEFS V12 NAO 30 perturb members showing a positive phase to the NAO today, dipping closer to neutral between the 9th and the 10th of January next week, back positive, 12th to the 13th of January, dipping back down negative again. This is a pretty significant drop between the 14th and the 18th of January to negative for NAO. And some of the models are actually hinting at blocking in the Northwest Atlantic with an upper level ridge setting up. So this will be interesting to watch. And now we turn our attention to the Pacific North American PNA forecast. Now this is really interesting. So many of you who like winter in the eastern U.S. just saw this ridiculously negative PNA pattern in December with a persistent trough over the western Canada and the western United States. Places like Seattle were getting snowstorms. I remember watching a football game a couple weekends ago, and it was just snowing like you couldn't believe in Seattle. They were just getting some extremely cold temperatures over western Canada into the Pacific Northwest when that PNA was so negative. Things are changing now, though, and I'll show you the forecast here in a minute. But in general, a positive PNA pattern is on the lower left here. When you get a positive PNA pattern, you get an upper level ridge and rising heights over western U.S., western Canada, a lot of times up into Alaska with a positive PNA. And then downstream of that upper level ridge, you get this deep trough from the Mississippi River eastward to the East Coast and get really cold temperatures in the east with a positive PNA. Bottom right, this graphic here, in the bottom right, shows a negative PNA. Now the opposite effect occurs where you get a persistent upper level trough and very cold temperatures over the western U.S., and then downstream of that trough you get upper level height rises across the southeastern U.S. up to the mid-Atlantic, and you get above normal temperatures across the east with a negative PNA. Now let's examine the models for today, the 7th of January. Today is showing a negative PNA. So we're still negative. Now if you look back at this blue line here, this shows the past. This goes back into late December. Look how negative the PNA was at one point. And look at the climb it's making right to today's date on the 7th of January. Now there's a little bit of a dip towards negative again, but by the 9th and 10th of January, oh, look at this. The PNA is actually going positive. And it remains positive all the way for about 5 to 6 days. Looking at the European EPS, PNA 50 perturb member forecast, again, we're starting off negative today on the 7th, over here on the very far left of the graph. Dipping a little bit further negative, but then we go up and we are climbing to positive 2 magnitude PNA. And it's remaining positive all the way out now until the 18th of January, according to this particular model. We look at the European EPS, PNA 50 perturb members. Negative to start for the PNA, rising positive, back down to neutral, and then drops negative. Now, this would not be a good scenario, right? We just got done with a very sharply negative PNA. If you're in the western U.S. or the Pacific Northwest, or you're in western Canada and you want winter, you like this. But if you're in the eastern U.S., you don't like this. So this is to be something to watch. The GFS deterministic PNA forecast, GFS deterministic showing a negative PNA today on the 7th of January, rising positive. By the 10th of January, remaining positive through the 16th of January, and then fairly neutral. You can see how it goes down negative briefly, then back positive, and then back down towards the zero line, back to neutral territory. So a lot of ups and downs there towards the tail end of this particular model run. And then the NSEP GEFS V12 PNA 30 perturb members showing a negative phase today, positive. They're around the 10th of positive PNA around the 10th of January, remaining positive all the way through the 16th of January, neutral for a bit, and then drops negative. Looking at the Eastern Pacific Oscillation, the EPO forecast, here are the examples of what we have on the left with a negative EPO and on the right with a positive EPO. You can see where the cold is favored. During a negative EPO, that cold is favored from the Arctic descending down into the United States. Northern Plains, Midwest, and working its way towards the East Coast with a negative EPO, because you have this nice upper level ridge that's situated over the Gulf of Alaska. And what goes up in the atmosphere, that ridge, has to come back down on the front side of the ridge. And so you get much colder air with a negative EPO for a lot of the United States, especially the eastern, Midwest, and East. Over here on the right, positive EPO showing a mild pattern. Pacific air floods the North American continent during a positive EPO. You got this Aleutian low sitting there in the Gulf of Alaska, which we had this for quite some time in December. And then we have higher pressure. There's higher pressure to the south of that Aleutian low with a positive EPO. Looking at the forecast models, European deterministic EPO forecast showing a neutral phase, the EPO becoming positive, and then dropping towards neutral, positive, and then whoops, there it goes. Down it goes to negative territory, according to the European deterministic after 13 January. European EPO, 50 perturbed members, showing a positive phase, the EPO today, back towards neutral around the 10th, positive again slightly through the 14th, and then turning negative after the 14th. The European EPO 50 perturbed members showing a positive phase to the EPO today on the 7th of January, dipping closer to neutral through about the 12th to the 13th of January, and then eventually working its way negative for a period basically between 14 January and 2 February. The EPO is forecast to be negative according to this model, before transitioning slightly positive as we go into the month of February. GFS deterministic EPO forecast showing a positive phase of the EPO today, working its way towards neutral, and then dipping sharply negative there around the 14th to the 15th of January, and then remaining negative through the rest of this particular runtime. It looks like out to about 24 January, a negative EPO. And then the ECMWF V12 EPO 30 perturbed members showing a positive phase, dipping towards neutral, and then dipping sharply negative. I look at the green line here, the ensemble mean. This EPO is really, on this particular forecast model, the GFS V12, really going strongly negative as we head into the third week of January. Now, taking a look at the polar vortex update, this is the GFS model. Now, on these particular, first of all, let me explain. These charts are the temperature anomalies, temperature plus anomaly in degrees Celsius, okay? And this is done at the 10 hectopascal level, or 10 millibar level in the atmosphere, which is about 18 miles above the Earth's surface. Whenever you see a green or purple shading, that indicates blue, green, and purple indicate colder stratospheric temperatures. The white and the bright orange, the darker maroon orange, that all indicates warming in the stratosphere, warmer temperatures. So on the left here, we're showing today, Friday, 7 January, and we see this pool of colder than normal stratospheric temperatures from northern Canada down into the United States, to the eastern U.S. We have this huge amount, this large area of warming, generally across the Arctic Ocean, north of northern Europe there. And then over time, this shows, the graphic on the right here shows next Friday, 7 days from now, 14 January 2022. It shows now, you notice this green coloring, these colder temperatures associated with the stratospheric polar vortex, they're stretched out. This is indicative of an elongated polar vortex. All right, whenever the polar vortex gets elongated or stretched out like a rubber band, it tends to deliver cold temperatures from the Arctic down into the United States. And much of the research of the past shows a stretching of the vortex tends to deliver the coldest temperatures in the eastern United States when it's a stretching. So right now, according to the GFS model, the stratospheric polar vortex will remain weakened and elongated over this period, resulting in more favorable cold patterns, cold temperature pattern into the eastern U.S. through late January. The European polar vortex, very similar, the forecast from the European model, showing, again, where the coldest temperatures are located from Canada down into the United States, coldest stratospheric temperatures, and then you have this area of pretty significant stratospheric warming over Europe, northern Europe, extending in the Arctic Ocean, and then working its way into western Siberia. Graphic on the right shows, again, I have a circle, oval shape here, that outline, showing the polar vortex and how it is elongated or stretched. It becomes more elongated in shape. Looking at the GEFS polar vortex forecast, generally showing a similar situation for today, 7 January 2022. Again, on the right-hand side here, this is the forecast for next Friday, 14 January, showing that elongated shape, okay? And I'll show you the ensembles here in a moment, but we're looking at multiple Arctic outbreaks starting next Tuesday, 11 January, as this polar vortex, the arm of it, elongates and kind of comes down closer to New England. It's going to deliver some pretty cold air next week. Now, I wanted to show you in tonight's presentation as well. I posted this on social media, but I find it really interesting. We look at the temperature anomalies. Now, this is the mean temperature anomalies, courtesy of PRISM. And for October here on the left, look at how much above normal things were. You know, on the order of 4 to 8 degrees, in some cases 5 to 9 degrees Fahrenheit above normal. In the upper Midwest, Ohio Valley, the coldest temperatures remain in the blue shading here over the southwest and western U.S. in October. Now look at November. It's like things flip-flopped. Now the warmest temperatures, above normal temperatures, were out over the northern plains, Intermountain West, southwestern U.S., and then the coldest temperatures then shifted to the eastern seaboard. So a big flip-flop between October and November in the temperatures. Now, look at December here on the left. This is where everybody in the east was saying, wow, where is winter? And it was even warmer from the south central plains, southern plain states, Missouri down to Texas, Louisiana, Mississippi. You were running 10 to 13 degrees Fahrenheit above normal during December. And that warmth expanded all the way up towards the upper Midwest and up and down the East Coast. Now, the graphic on the right shows the temperature anomalies so far for the month of January, the current month we're in. Now, you will notice that there is warming over the eastern United States. There's above normal temperature anomalies. But that is mainly due to the fact of how warm things were the first 2 days of the new year. The first 2 days of January, it was ridiculously warm. We're talking about 20 degrees Fahrenheit above normal in a lot of locations, from the southeast to the mid-Atlantic. And as a result, this is deceiving. We're 7 days into January now, and yeah, you're looking at this chart and go, wow, it's been a warm 7 days in the eastern U.S. Not exactly, because the larger the temperature departures are, the more this is going to look like this. Look at the signs of very cold air, though, across Montana, North Dakota, Minnesota, and the purple shading here extending down to the Mississippi River, western Illinois, and Kansas. Okay, so there's signs that we got a lot of Arctic air. In December, all this Arctic air was bottled up in western Canada, extremely frigid air. And now it's starting to come down into the United States. And that's really what I want you to take away from these temperature anomaly charts. Colder air is beginning to advance more readily into the United States from Canada. All right. And the overall theory I have here, we had an above normal October in the east, a below normal November, above normal December. Oh, what does that mean for January? Sometimes the atmosphere, the best forecasting techniques are by just looking at the overall anomaly maps. I go warm, cold, warm. I should probably be colder than normal in the east for January, right? If things were all equal and balanced out. So sometimes the atmosphere gets locked in these predictable patterns. Warm October, cold November, warm December, cold January. And it's really looking that way according to the models. If we look at the European EPS, this is the quad panel for the European EPS forecast. Looking at where the troughs are in the green shading and the ridges are in that maroon-orange coloring. Generally on the panel, on this slide here, I've got Sunday 9 January upper left. Over here in the upper right, I have Tuesday 11 January. Bottom left, I have Saturday 15 January. And then bottom right, I have Tuesday 18 January. So we're getting a glimpse of the ensemble, the EPS ensemble, out through the 18th of January. Okay, so for the 9th of January, this Sunday, we see this transitory ridge that's over New England, extending down into the mid-Atlantic. And, that's going to be a very briefly mild day on Sunday, the 9th of January, because this is that piece of the polar vortex that is going to work its way southeastward. And by Tuesday, look at where that piece of the vortex, not really a piece, but an extension or elongation, a spoke of the vortex, moves all the way down into New England. And that bitter cold extends from Maine all the way down to the mid-Atlantic, down to Virginia, by Tuesday, the 11th of January. Look at the rising heights over the central U.S. In general on the 11th, on Tuesday, the 11th of January. Over time, that does translate towards the east. Here in the bottom left, now we work our way towards 15 January, mid-month. I want you also to notice this maroon orangish shading there in the northwest Atlantic, because that is indicative of a potential negative North Atlantic oscillation. But you also notice the blue shading here. We had a transitory ridge on next Tuesday, the 11th of January, be replaced by this trough, the blue shading. And these upper level heights are beginning to rise over the western U.S. into western Canada. So now by the time we get to the 18th of January, we have an upper level ridge working its way towards Greenland, associated with a negative North Atlantic oscillation, or NAO, and we have a ridge, higher heights there into Alaska, with a downstream trough and a pathway for colder, more Arctic air to move southeastward into the United States. Looking at the GEFS ensemble for today. Similar situation here, upper left 9 January, upper right 11 January, lower left is 15 January, and then bottom right is 18 January. Look at how things change over time. Again, this Sunday, the GEFS is in agreement with the EPS, showing that upper level ridge over the eastern U.S. and a brief mild day. We have colder air beginning to advance with this trough, working its way southeast. And then by Tuesday, we have one of the colder days of the week. Again, with the polar vortex extension on into Maine, New Hampshire, Vermont, extending southward right into Virginia. And the bottom left shows that trough lifting out and being replaced by a little bit of zonal flow, west-east flow in the jet stream, a little bit milder conditions. But then look at this in the bottom right. The heights rise, the ridge builds in the Gulf of Alaska, it extends northward right into the Gulf, right into the Alaska itself. And we have this downstream trough just transporting cold air from northwestern Canada into the United States. All right. So the ensembles are indicating a colder pattern for the eastern U.S. in late January. This is today's ensemble runs. This was the 00Z runs for today, 7 January 2022. And you'll notice the main features here. This upper level ridge is key. This is associated with that positive PNA, a negative EPO, and we get this nice deep trough. Look at this flow. The jet stream is coming straight from the northwestern Canada, right on down into the Midwest and the East Coast. And so you get much colder temperatures according to the EPS model here on the left for the United States, central and eastern U.S. And then on the right here, we're showing the ECMWF 500 millibar height anomalies, again showing a ridge and general rising heights in the Gulf of Alaska by 22 January, it's the same time period. And we have a downstream trough with colder air flowing into the Midwest and eastern U.S. by 22 January. So here are my final thoughts on tonight's video. First of all, the MJO is in phase 8. Finally, we made it. So congratulations, all you winter weather fans in the eastern United States, because this is exactly what we wanted to get to. That phase 8, though, is generally forecast to transition to a null phase by 19 January. So the MJO and the convection and upward vertical motion in the Pacific may no longer be a factor, as much of a factor in establishing the long wave pattern for the United States, the troughs and ridge placement. Now the CFS, we can't discount the CFS. It is indicating a more amplified MJO phase 1 by late January, and that would correlate with colder temperatures across the eastern U.S. we're in phase 8 or phase 1, expect the cold to be in the east. La Nina conditions continue across the equatorial eastern and central Pacific, and we're sitting today on 7 January 2022 at 1.04 degrees Celsius below normal. Water temps in the Nino 3.4 region. This favors an upper level ridge and milder temperatures across the southeastern U.S. Sea surface temperature anomalies, we're seeing over the Pacific cooler than normal water across the Gulf of Alaska and the Northeast Pacific, with warmer than normal water over the North Central Pacific Ocean. And that's indicative of a negative Pacific Decadal Oscillation, PDO, and that's generally associated with upper level ridge and milder temperatures across the eastern U.S. Models are indicating a neutral to occasionally positive Arctic Oscillation, or AO, phase through middle January, then potentially going negative in late January. We'll have to watch that. Now, a negative phase AO favors cold temps across the eastern U.S., with higher pressure and warmer temperatures over the Arctic and lower pressure in those cold temps across the mid-latitudes. A positive phase of the AO, on the other hand, that favors warmer temperatures across the eastern U.S. with a more zonal west to east jet stream, more Pacific air, vice Arctic air. Models are indicating a neutral North Atlantic Oscillation, or NAO, phase through the end of January. Some models are actually indicating high latitude blocking occurring over the Northwest Atlantic and the return of a negative NAO phase in late January. And we just looked at that in the Ensembles, right? Whether we're looking at the EPS, you see the upper right-hand portion of these specific graphics showing that orange shading indicative of ridging. As well as on the GEFS, we see the same thing. We see this ridging. In fact, GEFS actually strengthens ridging over the Gulf of Alaska, into Alaska, North Pacific, and then also into Greenland. All right, so a negative phase AO, or NAO rather, favors cold temps across the east with a large blocking ridge over the Northwest Atlantic. A positive phase NAO favors warmer temperatures across the eastern U.S. All right, so additionally, models are indicating a positive Pacific North American pattern, a PNA, after 10 January. Now, this is huge. This has been predominantly negative through the month of December. We had a very mild eastern U.S. in December because of that persistent southeast ridge. But now with the positive PNA, the heights rise in the west, and that results in a downstream trough over the central and eastern U.S., so we get colder temps over the east. With that positive PNA, I want to mention too that the ridge axis is very important, the location of it. It's critical to what kind of sensible weather we have here in the United States during the winter season. The closer the ridge axis is to the western Canada and the west coast of the United States, the more favorable the cold air, higher probability we'll see much colder air into the eastern U.S. Models are indicating a sharply negative Eastern Pacific Oscillation, or EPO, after 15 January. That's very important because that negative EPO favors an upper level ridge over the Gulf of Alaska and the Northeast Pacific with a downstream trough and colder temperatures extending from the northern plains to the east coast with a negative EPO. And then models are also indicating a weak, elongated stratospheric polar vortex through late January. Really interesting stuff. So that favors colder temperatures across the U.S. And multiple shots of very cold air are potentially showing up on the model data as we head into not only next week, 10, 11, and 12 January, but also the following week, the third week of January. So the overall assessment, the pattern has changed since late December for sure. The biggest changes include a rising upper heights, ridge farther to the east, into the western U.S. and Canada, a weak, elongated stratospheric polar vortex, a negative EPO and WPO. I talked about the WPO earlier. The stage appears set for multiple cold air intrusions descending down from Canada into the Midwest and East Coast between now and late January. Now, we will see quick rebounds in temperatures between cold air outbreaks or intrusions, but they'll be generally short-lived. We're watching also the potential for a major coastal storm near or just offshore the East Coast between 16 and 22 January. And if things come together at just the right time, we could actually see a potential significant, even shutdown type winter storm Too early to give specific details because it's still well out in the future, but it's definitely something that we're going to keep an eye on. Overall, the takeaway from tonight's video, the ensembles are in general agreement on a cold weather pattern for the eastern U.S. the third week of January as an upper-level ridge builds into Alaska and western Canada, and the trough deepens in the eastern U.S. All right, that wraps things up tonight in my video. I really hope you enjoyed it. Forgive me occasionally for my clearing my throat, but it's really dry tonight, and I do not have any water nearby to occasionally take a drink. So I apologize for all the throat clearing. I get the tickle in the throat. But in general, I hope you enjoyed the video and the latest update on the Teleconnections discussion. Please feel free to follow us on social media. I wish everybody, I think it's going to be a great, interesting pattern the next 2 weeks as we head from mid to late January. And I can see a lot of troughing in the models, a lot of cold temperatures descending in the eastern U.S., and we get some disturbances rotating through the pattern, a couple of disturbances in that subtropical jet, and we could really have an interesting winter storm or two in there in that period. All right, everybody, I wish everybody to stay healthy, most importantly. Take care of yourself, and hope everything is going well in the new year in 2022. Thank you so much for subscribing to my channel. Looking forward to posting some more information as the weather pattern unfolds. Take care and God bless everybody. And most importantly, if you're in the east tonight, stay warm just like these dogs are doing. Take care, everybody.